This is the Math 3 Unit 2 Whiteboard Review Part 2. Number 1 is a sum of cubes, and I am asked to find the factored form, the real solutions, and the imaginary solutions. So I'm going to start by factoring. I know that if I write each of my terms as my base to the third power and my base to the third power, then I can more easily write the factored form, which is going to end up being a binomial times a trinomial. My binomial comes from my two bases, so in this case x and 4 are my bases. My trinomial, I can write out this x cubed as x times x times x. I can write out 4 to the third power as 4 times 4 times 4. And that actually helps me write my trinomial, because I'm going to be grouping these into 3 groups for my trinomial. X times x gives me x squared, x times 4 gives me 4x, and 4 times 4 gives me 16. And then in order to get all of my signs, I use the acronym SOAP. S stands for the same, so my first sign will be the same as the question that I have. My second sign will be the opposite of my question, which if this is a sum, then I'm going to take the difference for my second sign. And then my third sign is always positive, so that last sign will always be a plus sign. That is my factored form. And you can just tell me what the two factors are. You don't have to set it equal to 0. But I like writing my whole entire equation out, because that's what I started with, was an equation. My real solutions, well, I know that these things inside parentheses mean I'm going to multiply parentheses times parentheses, which means if I multiply these two things together to get 0, either x plus 4 equals 0, or my trinomial, x squared minus 4x plus 16 equals 0. Well, x plus 4 equals 0, that's pretty easy to solve for x. I'm just going to subtract 4 on each side. Or you can tell me, what number do you add 4 to get 0? Negative 4 plus 4 equals 0. That is a real solution, because I can plot that number on a number line. Over here, if I multiply 16 times x squared, I get 16x squared. And that means my numbers that I factor to need to multiply to 16 and add to negative 4. Well, no numbers multiply to 16 and add to negative 4 that are real, so I'm going to use the quadratic formula in order to determine my imaginary solutions. All right, simplifying that, a negative 4 becomes a positive 4. I'm going to simplify under my radical. Negative 4 squared is 16. And then I'm going to subtract 4 times 1 times 16, which is subtracting 64. So 4 times 1 is 4, 4 times 16 is 64, and I'm subtracting that value. Then simplifying 16 minus 64 gives me negative 48. I'm going to factor the negative 48. So we'll do that on this left-hand side where I have some more room. So first of all, the negative means if I get a negative under a square root, that gives me an imaginary number. So this is really I root 48. And then I can factor the 48 to 4 times 12. And then 4 times 3. I could continue to factor this 4 to 2 times 2, and this 4 to 2 times 2, and circle 2 groups of 2, but since I already have a pair here, I'm going to bring this out as a 4. So the 4 is going to come to the outside. which means the 3 stays on the inside. So I'm going to rewrite my radical. The 4 out front stays the same, plus or minus. The denominator stays the same. I'm just rewriting the radical right here. I know that I came to the outside. I also brought a 4 to the outside, so that's 4i. And the 3 did not have a pair, so it stayed on the inside of the radical. After that, all of my terms are divisible by the same number. I have 1, 2, 3 terms. The 4 is divisible by 2. So I do 4 divided by 2 is 2. 4 divided by 2 is 2. And 2 divided by 2 is 1. This gives me 2 plus or minus 2i root 3 all over 1, which means my answer to my imaginary solutions is 2 plus or minus 2i root 3. I only have one real solution, but I have 2 imaginary solutions. Anything over 1 is just itself, so that's why I got rid of my denominator. For number 2, solve, graph, and write an interval notation. The graph is on a number line, so you'll just graph that on a number line. But I need to solve for x before I can graph it. The very first step is to isolate your absolute value. So I'm going to divide each side by -3. When you divide by a negative, your sign flips. So -24 divided by -3 is positive 8. All right, x plus 5 is greater than or equal to 8. That means, first of all, an absolute value is talking about a distance. My distance away is greater than 8. That makes this an OR problem. If this was a negative number on the right-hand side, it would be a special case, but this is not a special case. If it was a less than or equal to sign, that would be an AND problem. But it's a greater than sign, meaning my distances will be greater away in each direction, so it's opening to the outside. So I am going to split this into 2 inequalities. You only split it for OR problems. So we're going to split this into x plus 5 is greater than or equal to 8. That is one of the things I'm splitting to. Notice that everything is the same except for I don't have the absolute value anymore, because I'm just talking about whatever's inside the absolute value needs to either be greater than or equal to 8. In other words, if I replace the x plus 5 with a 9, would this statement be true? The absolute value of 9 is 9, and 9 is greater than or equal to 8, so that works. But if I replaced this with a number that, well, let's go back. Let's split our other side first before I talk about that. We also need to split this to the opposite number on the other side, which is -8. Because if I plug in a -8 for x plus 5, I get -8, and I take the absolute value of that, and I get 8, and 8 is equal to 8, so that's why one of my solutions would be -8. But what other type of numbers do I use? Do I not use numbers that are greater than -8, or do I use numbers that are less than -8? -7 is greater than -8. If I put a -7 in here, I get the wrong answer. The absolute value of -7 is 7, and 7 is not greater than 8. So I want numbers to the left of -8, which would be like -9, -10, -11. If I put a -10 in here and take the absolute value, I get +10, and +10 is greater than 8. So that's the reason why this works. What you need to remember is when you have an OR inequality, which is greater than or equal to, these two things produce OR inequalities. If you have an OR inequality, you split it into 2 inequalities. The first one will have the same sign and the same number. The second one will have the opposite number. So the opposite of 8 is -8, which means we need to take the opposite sign. Now I can solve for x for each of these. I'm going to subtract 5, and I get x is less than or equal to -13. My other solution, hence the or part of my question, is going to be if I solve the other inequality, I get x is greater than or equal to 3. 8 minus 5 is 3. -8 minus 5 is -13. So my solutions can be equal to -13. They can be equal to +3. They can be greater than +3, which is to the right. They can be less than -13, which is to the left. And this also represents my OR inequality. I have numbers that are less than -13 or greater than +3. Two different directions means two inequalities that you're writing out. You're separating them. If it's in between, you only have one inequality. So I have solved my inequalities. I have graphed them on the number line, but I haven't written them in interval notation, which is very important. I'm going to use my number line to write my interval notation. So these are all x values, because this is an x-axis. So if I go to the left forever, that means my interval starts from -infinity and goes until -13. -13 can be used as an x value, so I want to use a bracket. But I need to skip over numbers like -12, 0, 1. All of those numbers need to be skipped over because these are not solutions. I don't have any more solutions until I get to +3. And then I have a bunch of solutions, and this will go to the right forever until infinity. So any number that's in between these values is a solution for x. So I need to write it out as an interval. Or inequalities will always have unions because you're going to the left or to the right. And inequalities will be numbers in between. So you'll only have either one set of parentheses or one set of brackets. You won't have a union for and inequalities. There's an example of an and inequality on number 5. So if you want to skip ahead to look at and inequalities, that'll be on number 5. Number 3. This is an equation, but still absolute value, so I still want to isolate my absolute value before I continue. So I subtract 7 from each side, then I divide by -3. Remember that you're getting rid of addition and subtraction first, then you're getting rid of multiplication and division. So when I do that, I get 3x minus 6, which is inside my absolute value still, equals a negative divided by a negative is positive, so +7. What does this mean? This means anything on the inside of this inequality, I have to take the absolute value of to get 7, which means this inside could be equal to 7. But it also means this inside could be equal to -7, because if I take the absolute value of -7, I also get +7. So I have 3x minus 6 equals 7, and 3x minus 6 equals -7. And then I solve each of these. So we're going to add 6 to each side. And then divide by 3. So I get x equals 13 over 3. I'm going to solve my second equation. Add 6 to each side. -7 plus 6 is -1. Divide each side by 3. And I get x is equal to -1 over 3. Graphing that on a number line, your two solutions will be closed points because your x values will be equal to those two values. at negative 1/3 and 13 over 3. Number 4, absolute value equation. Again, I have to isolate my absolute value. Always isolate first. I haven't completely isolated yet. I need to divide by 4 on each side. 4 divided by 4 is 1. 1 times x minus 3 is just x minus 3, so essentially these equal 1 and they cancel. But this side I don't want to cancel out because it's the only thing left on that side. So negative 4 divided by 4 is negative 1. Okay, now I need to analyze this. I forgot to analyze number 3. When you isolate your absolute value, you want to look at that number on the right-hand side. If it's a negative, it's a special case. If it's not a negative, it's not a special case. So, on this problem, I have a special case. So what is the special case? Well, this is saying the absolute value is equal to negative 1. Any number you take the absolute value of, you're going to get a positive number. So this is saying a positive is equal to a negative number, or a positive is equal to negative 1. No positive solution can be equal to a negative number, so this is no solution. And you would not need to graph a number line because there would be no solution. You would just have a blank line. Number 5. This is an inequality, but I still need to isolate the absolute value first, so I'm going to subtract 3. Now that my absolute value is isolated, I need to analyze if this is a special case. This 2 is positive, not negative like on number 4. So this is not a special case. The next thing to determine is if it's an AND problem or an OR problem. Remembering back at number 2, OR problems mean we split it into 2 pieces because my intervals will split into 2 pieces and my shading will split into 2 pieces. That happens with greater than or equal to problems.
Isabella Alvarez, please report to the attendance office. Isabella Alvarez, please report to attendance.
This is not a greater than or equal to, so it's not an OR problem. It's a less than, because less than or equal to are AND problems. The reason for that is because my distance away from 0 is going to be 2 in each direction, either to positive 2 or to negative 2. All of my distances that are less than 2 away have to be on the inside, not on the outside.
Lily Hayward, Carson Okerson, Jaden Johnson, please report to the attendance office. Jaden Johnson, Carson Okerson, Lily Hayward, please report to attendance.
So whatever's inside my absolute value has to be equal of a distance of 2 or less away from 0. So we'll have it all on the inside here. This is not the graphed solution. This is just explaining why it's an AND problem. But if you remember that less than problems are always AND problems, then you will not split these type of problems. So never split a less than problem. So that just means this needs to be inside of these 2 numbers. So negative 2 to positive 2 has to go in numerical order. And your x minus 1 needs to be in the middle of those 2 numbers. Your sign stays the same because negative 2 is the smallest number I have, it'll be less than every other solution that's in the middle. And because 2 is the largest number I have, my solution cannot go outside of that value. But I still need to solve for x. So to get x by itself, I need to get rid of this minus 1, which means I need to add 1, but I need to add 1 to all 3 of these pieces or statements. So negative 1 plus 1, that cancels because it equals 0. and x plus 0 is just x. 2 plus 1 is 3.
Ariana Gutierrez, please report to the attendance office. Ariana Gutierrez, please report to attendance.
Negative 2
Jasmine Rodriguez
plus 1
Nicholas
is negative 1.
Rodriguez, please report to attendance. Jasmine and Nicholas Rodriguez, please report to attendance.
I can't have x values equal to these two numbers because there's no equal than sign underneath. So I need open points at negative 1 and positive 3. My x values, negative 1 has to be my smallest, on my smallest number, so negative 1 has to be less than x, which means x is greater than negative 1. But x has to also be less than 3. So this is my solution. Right here, I've solved. Right here, I've graphed, and I also need to write it in interval notation. So my solutions range from negative 1 to 3. I cannot have a value of negative 1 and I cannot have a value of 3 because there's no equal to sign. So I use parentheses to show that my values for x cannot be equal to negative 1 or equal to 3. Only values in between those two numbers. Number 6, list all labeled solutions that are a solution, labeled points that are a solution for f of x. That means every point on your f function. My f function is my quadratic one. So the points on the quadratic function are a, c, d, and e. Part B, list all labeled points that are solutions for g of x. G of x is my linear function. So all of the points on g of x are a, b, and e. List all labeled points that are a solution for f of x equals g of x. That means when they intersect, which are the points a and e. Part D, list all labeled points that are a solution for f of x equals 0. That means on my f function, my y value is going to be equal to 0.
Cadence Gilchrist, please report to attendance. Cadence Gilchrist, please report to attendance.
My f function is the quadratic function. My y value equals 0 along my x-axis. So A and D are solutions for when f of x equals 0. If it said g of x equals 0, that would be where g of x crosses the x-axis, which would only be point A. But this is talking about function f. Number 7. So we're given the points of f of x, g of x, and h of x. I'm going to plot each of those points on the stretched out x-axis below so that we can see which one we're talking about for each. So this first one, I'm going to plot in purple. Hopefully you can see that. Okay, so the first point I'm going to plot is 0, 3. Then after that, I'm going to plot 1, 1. And these are the x values. So I'm just going up 3, up 1, up 3 again, up 5, and up 7.
Nicholas Rodriguez, please report to the attendance office. Nicholas Rodriguez, please report to attendance.
Okay, so for g of x, I'm going to do that one in red. So I want to go to the point 0, 0. So all of these g of x values will be my height here. So if I'm going negative 3, I'm going down 3. 2, 1. 3 is at 7. 4 is at -2. And I just want to determine between which intervals these two functions cross. So there they crossed once, and then they'll cross again when this comes back down. And then you just shade the intervals where they cross. So they cross between 2 and 3, and then they cross again between 3 and 4. Okay, let's see, for h of x, let's do that in green. So I'm doing f of x again. I'm just going to copy that one from above. And then when I check h of x, do -4, -1, 0, 4, which is below 5. So I'm going to check them when they get close like that. And then -3. So you'll see that these two functions do not cross, and you want to explain why. So there is no solution to f of x equals h of x because the functions do not intersect. Okay, so for part C, I need to do G, which was red, and H, which was green. So I'm going to plot G again. If you need to put the y values that these are at, that would be a good idea to make sure you know where they're crossing. H was green, so it's down here. Okay, so you can see when they cross because it's when the points change places. So right now, red is above green. When I go to the next point over, green is above red. So they cross there. And then the next point over, green goes back below. And then it stays below for the rest of the time.
Brandon Chappell, please come to the front office. Do you have an item to pick up? Brandon Chappell, please come to the front office at this time.
So it crosses once between 0 and 1, and again between 1 and 2. Number 8, graph the system of inequalities. So starting with the linear system, I'm going to plug in values that are best for this linear function. I always want to plug in the number that makes whatever's inside my parentheses equal 0, so 1 is a good number to plug in. I'm going to do 1/2, 1 minus 1, plus 2. Order of operations says parentheses first, so inside my parentheses, 1 minus 1 is 0. Then multiplication, which gives me 0.
All staff, please post your attendance. Thank you.
0 plus 2 is 2. So the 0.12 is a solution to this inequality. And then I can plot the rest based off of my slope because it's linear, so it's a straight line. So I can go up 1 over 2, up 1 over 2, up 1 over 2, down 1 back 2. So I have this function. I need to determine if I'm going to graph a solid line or a dashed line. So this equal to part under my less than sign means I'm going to graph a solid line. The less than in front of that means I'm going to shade below. Okay, now I'm going to graph this absolute value function. The best number to plug in here is the number that makes whatever's inside the absolute value equal to 0, so a -3. So -3 plus 3 is 0. The absolute value of 0 is 0. Then I can do multiplication. 3 times 0 is 0. 0 plus 4 is 4. So -3 up 4. You can also do that based off of your translations. I know that if this is plus 3, that means to go to the left 3. And if this last number is plus 4, that means to go up 4. So my vertex is -3, 4. That's the same point that we solved on this right-hand side. Then I can use, since it's absolute value, they are straight, linear absolute value, so they're straight lines. I can use this -3 to go down 3 over 1 as a slope to get to my next points. All right, and then I don't have an equal to sign under this, so I need to do a dashed line. That means it's not equal to those points that cross on this dashed line. And then less than means to shade below, so I'm going to shade underneath the absolute value. And the solution is the part that overlaps.
Please report to the attendance office. Ethan Navarrete, please report to attendance.
So the part that overlaps is going to be underneath both functions. It has to be underneath both at the same time. So this is the region that my solution is. Okay, write one ordered pair that is a solution. So first of all, any point inside here is going to be the solution. So I'm going to go 1, 2, 3, and let's just go down far enough to get in the middle. So -3, -3. Is -3, 1 a solution? So if I go left, 1, 2, 3, and up 1, this is not a solution because it is not in the part that overlaps. It's only a solution to y is less than my absolute value function. It's not also a solution to the first piece of my function, or my first function. So that's no. And on your test, you're going to have to show why. So you're going to plug in -3 and 1 to your x and y values in both equations. So 1 is less than or equal to 1/2. -3 minus 1 plus 2. That's the first equation. You're also going to plug that into the second equation. So 1 is less than -3 times -3 plus 3 plus 4. This part's easy, but let's go from left to right. 1 is less than or equal to -3 minus 1 is -4. Order of operations, parentheses first, I get -4. Then multiplication. I have no exponents, so multiplication comes next. Half of -4 is -2, and -2 plus 2 is 0. So this means 1 is less than or equal to 0. Positive 1 is not less than 0, so that does not work. You can just show that it's not a solution if it doesn't work for one function. If you want to show both, you can do that. But if one of them works, you cannot assume that they both work. Because in this case, I get -3 plus 3 is 0. -3 times the absolute value of 0 is 0. 0 plus 4 is 4. 1 is less than 4. So this part works and is true, But if it doesn't work for both of them, it's not a solution to the system. Systems mean each point is a solution to both functions. Number 9. State the domain of this function above. So I want to go from x value to x value. My domain has a closed point when we start, so I want brackets. There's no holes. All of these x values in between are included. So my domain is -7 to +6. State the range from bottom to top. The lowest value is -3. The highest value is +4. So my range goes from -3 to +4. I'm using brackets because those points are included on this function. Relative maximums means you need to change from increasing to decreasing, like the top of a peak or a top of a hill. Here is where we're changing from increasing to decreasing. Do I have any other points? This is increasing to constant, so that doesn't count, which means 3, 4 is my only relative maximum. Relative minimums need to change from decreasing to increasing, so it's like the bottom of a valley. This is not my relative minimum. This is the lowest part of my graph, but it's not my relative minimum because it's not changing from decreasing to increasing. Right here, decreasing to increasing, I do have a point at the very bottom, which is 0, 0. And then over here, also not a relative minimum because we don't see it go back up again. Where is f constant? State the open interval. So my x values, where my graph is constant, go from -3 to -1. So you need to state the x values that it's talking about there. I use parentheses because it's an open interval, so we'll never use brackets on that one. The open intervals for f and g will also use parentheses. We're going to list where f is increasing, so let's go ahead and highlight all of the increasing portions of this function. Starting from the left, we have one piece that's increasing there, then we're constant, decreasing, increasing, and then decreasing again. So even though this is two separate pieces, it continues to increase along all of those x values. So we only have two intervals for increasing. The first one goes from -7 for my x value and stops increasing at -3 because that's where it turns constant. And then the next one starts at 0 and goes to +3. My two increasing intervals need to be connected with my union. Okay, and the next piece we're talking about decreasing, so where it's going down from left to right. So this is constant, then decreasing because it's going down, and then we decrease again at the very end. So this is from the x values of -1 to 0, and then from 3 to this x value of 6. So from -1 to 0, and then 3 to 6. Open intervals mean use parentheses. If I have two intervals, I need to connect them with the union. Nope, not the end. One more question on the back side, don't forget that. Very similar to the other side. State the open intervals where f is increasing. This portion is increasing, so that's from 2 to 5. Decreasing, I should have done the same colors I did on the opposite page. I have two decreasing intervals, so that's from 1 to 2, and then again from 5 to 9. State the domain. My domain is my x values. This is where you'll want to use parentheses or brackets, depending on if those are included. So all of these values are included, so I don't need any parentheses. So from -4 all the way to 9 are my x values in brackets. My range from bottom, my lowest value here is 0. My highest value is 3. So that's from 0 to 3. Oh, sorry. It's too low. And then state the coordinates of any relative minimums. Has to change from decreasing to increasing, which is basically blue to pink. So the minimum would be 2, 0. This point right here, 2, 0. The maximum will be changing from blue to, or pink to blue. The top of a peak, which will be this point of 5, 3. Write a 3-piece piecewise function f that accurately represents the graph of f shown above. So, this will be extra credit on your test. Starting with our constant, our y value on every single point here is equal to 2, so this is y equals 2. My quadratic function, I'm going to write y equals a times x minus h squared plus k. This is vertex form. Starting with plugging in my vertex, that's my h and my k value. So my vertex here is 2, 0. So I'm going to use 2 as the h and 0 as the k. So if I add 0 to the end, I don't have to write that. Then I'm going to solve for a by plugging in another point on this function. So I'm going to choose the point 3, 2. Plugging in the 2 for y and the 3 for x. 3 minus 2 gives me 1. 1 squared is 1. A times 1 is just a, so a is equal to 2. My quadratic piece of my function is going to be this piece with the a value plugged in. Please plug in the a value of 2. And then the absolute value function. Let's see. Let's make sure this is absolute value. If the slope's not the same, it's not absolute value. So if we go down 1 over 2 to the left, I want to see if this slope is the same. So going down 2, I'm going to the right. 1, 2, 3, 4. Good. So this was down 1 over 2. This was down 2 over 4. So 1/2 is equal to 2 over 4. So this is an absolute value function. I could plot a point right here. And I just want to make sure that that's where it intersects, but it was hard because it didn't have a point plotted there. So this is absolute value. And my equation for that is m times x minus h plus k, where the x minus h is an absolute value. My slope is down 1 over 2, and my v for my absolute value is opening down. So this is a negative slope. My vertex is this point up here, which is 5, 3. So I'm going to plug in the 5 and the 3 for my h and my k. Now you need to write the 3-piece piecewise function. So f of x. It needs to go in order from left to right of your graph. So we start with the constant, then the quadratic, and then the absolute value. Don't forget all of your restrictions. So I want to know what the x values are at each of those places. So for the constant, we go from -4 to 1. So -4 is less than or equal to x, which is less than or equal to 1. For the quadratic, we go from 1 to 3. 1 is less than x is less than or equal to 3. You'll notice that I didn't use an equal to sign on that one. That's because I already used an x equals 1 on the previous step. Even though I could plug in 1 for this equation and get the correct point on the quadratic function, you don't want to write 2 of the same. So you can't write equal to 1 at 2 different places. And the last one, my absolute value function goes from x equals 3 to x equals 9, so all the way across. So 3 is less than x, which is less than or equal to 9. And that is your piecewise function. Remember, that's extra credit on your test. So that completes Math 3 Unit 2, Whiteboard Review Part 2.